So this study here looks at a 3-year duration that we've been investigating, looking at text analysis from student responses and how those lessons learned can impact, and we can use them for teaching enhancements in the future. As we know, engineering education is a really important field, and due to a lot of the types of assessment, we're looking at ways to innovate and make assessment more interesting, as well as the more opportunities to give students feedback based on this assessment as well. So we know that formative assessment, that is assessment that is not worth any marks, is one way that we can do this and is able to provide insights for us moving into the future. The technique that we're looking at in this study here uses text responses with text analysis techniques. Just introducing the topic of assessing conceptual understanding. So conceptual understanding is sometimes tricky to assess. The way in which we're measuring it in this study is looking at a piece called a concept inventory. So a concept inventory is a set of multiple choice questions that have been specifically and carefully designed by an expert. The multiple choice questions include firstly the correct option, but they also include a lot of distractor options, which are common misconceptions that students might have with regard to the particular concept that's being tested. So as we know, positives about multiple choice questions, they're easy to score, so they can be computer marked for speedy feedback, which is something that's used a lot of the time for both formative and summative assessment. But these concept inventories need to be designed by experts and checked to make sure those questions have the correct option and are eliciting those misconceptions and actually testing students' knowledge. Another downside is that the concept inventories don't obviously account for guessing, so students can guess the correct option or they can eliminate and deduce without actually having the full understanding of the particular field that's being looked at. So this piece of work here, which builds upon previous work, looks at adding a text component which gives more insight. So the student is given 4 multiple choice options, and then they're asked to write about why the option that they picked is correct, and that allows us to obtain more information. The 2 research questions we're investigating here are initially, what are the similarities and differences observed in students' conceptual understanding scores and those persistent misconceptions? And then secondly, looking at the text analysis, how can we use text analysis to help discover the link between students' scores on conceptual understanding tests, their confidence, and possible teaching strategies as well. The method we looked at is a multi-year case study. So we looked at this study over 3 years. We used a concept inventory with, as I said, adding short text responses to the end. The concept inventory that we looked at in question was the Signals and Systems concept inventory, and we used 15 questions from that. There's both discrete and continuous versions, and they were administered in a 4th year unit. So looking at the results, we ran this across 2014, 2015, and 2016. We looked at both discrete and continuous versions of the concept inventory, and we ran a prior one at the beginning of semester and a post-test at the end of semester. If we initially look at some information we can see, so these here are the average marks from those prior and post-tests. We see between every prior and post example given, there is an improvement in the score, which is definitely a good and positive sign. That's the first thing that we get from the pure results. We also have the standard deviation, so we can see very similar for most of them, and the population size that we surveyed as well. This one here is the largest score, so that was the post-test. We attribute some variance in the score due to the small sample sizes that we looked at as well. So that's another point to consider for this study. Looking at the discrete test results. So the results we looked at were just overall, and they do paint a bit of a picture. But we then moved on to dividing it into 6 different topic areas which we looked at. So take, for example, the maths topic area here. We looked at it across 3 years, 2014, 2015, and 2016. But the important bit to look at is the part on the top there. So if you look at the one in the middle, 2015, in green there, we actually see the improvement. So you can see that between the prior test, which got around 70%, to the post-test, which got around 80%, there's a 10% improvement there. So by looking at it visually like this, it's easy to see where those improvements, or sometimes very minor decreases, do occur. And we can do that across all the different topic areas here as well. This allows us to target into areas which might have significant improvement, so things that were explained well, or ones that don't have much improvement, which could be targeted on. We chose to focus on, for the rest of the study, on this topic area of sampling, due to its initially low scores and significant improvements as well. So we wanted to delve a bit more into this topic area. Here's the results across 2015 and 16 as well for the continuous test. We chose to focus just mainly on the discrete sampling area though. Breaking this up even further now. So now we're throwing in some information which we were able to get from the text that was added. So these graphs here represent the total amount correct versus the amount that was guessed by students. So by pulling out keywords such as guessed or eliminated, which we asked the students to use, we can see in these graphs here, the shaded bits down the bottom of each bar is the percentage of students who guessed the correct question correctly, and the total length of the bar is how many students got the question correct. So straight away, easy to help identify those areas where students were guessing a lot, which are areas which might need to be looked at or explained in further detail. One other insight we looked at from just the text component, we looked at 2 questions here from that sampling area. So question 7 on the left and question 8 on the right hand side. We see from these questions here, if we so these diagrams here represent different concepts that the students talked about in the question and their links and relationships between them. But if we focus on the shape, question 7 was one that when students got correct, they all had very similar answers, and the rate of guessing was quite low. But if we look at question 8 on the right hand side here, this was one that had a very high guessing rate, even though a lot of students did actually get this question correct. And our hypothesis is, because of that large amount of guessing in question 8, the shape of question 8 there appears much more disjointed, as opposed to that of question 7, which is much more neatly joined together, and the concepts link and overlap a lot. So that's another insight that we were able to grab from that added text component. So just in conclusion, multiple choice and text components together provide more insights, so that guessing information and those concept maps would not be able to be deduced from just the multiple choice data alone, so we needed that added text component as well. Consistent areas of persistent misconceptions were identified, so looking at those that area such as sampling, which was consistently getting low scores from students, we were able to identify that and hone a bit more in on it. And future work that we're looking at will involve investigating more text analysis techniques and hopefully getting more insights and being able to provide more feedback to students as well. Thank you.